Construction of flexible pavement. Introduction. Pavement. Pavement is load-bearing and load-distributory component of road. Purpose of pavement: load support, smoothness, drainage, all-weather operation, direction and guidance. Type of pavement. So there are two types of pavement. Type of pavement can be flexible pavement or rigid pavement. So flexible pavement, those pavements which reflect the deformation of subgrade and the subsequent layers to the surface. Rigid pavement, the pavement are associated with rigidity or flexural strength or slab action, so the load is distributed over a wide area of subgrade soil. Rigid pavement is laid in slabs with steel reinforcement. Flexible pavement. The advantages of flexible pavement include adaptability to stage construction, availability of slow-cost types that can be easily built, ability to be easily opened and patched, easy to repair frost-heavy and settlement. So, of course, there are some disadvantages, and these include higher maintenance cost, shorter lifespan under heavy use, damage by oils and certain chemicals, weak edges that may require curbs or edge device. Thickness design. Several procedures are used based on volume and weight of traffic. Load supporting capacity of soil is important. Heavy vehicle wheel load has greater impact. Traffic analysis is necessary. Design are chosen based on design traffic in terms of cumulative numbers of standard axles, and the second one, CBR value of subgrade. So, total thickness of pavement consists of bituminous surface, that is wearing course, base course, subbase, subgrade. Here you can see some layers of the road. So the lowest one, subgrade, then subbase, base, and wearing. Wearing is asphaltic concrete layer, and there are some shoulder area and aggregate layers. And here you can see that subgrade is soil. Wearing course. Three types of bituminous layers. So the first one, bituminous macadam, then penetration macadam, built-up spray grout. Bituminous macadam. It consists of crushed aggregate and bituminous binder heated and mixed in a hot mix plant at specified temperature, transferred to the construction site, laid with a mechanical paver and compacted by a roller. Material used, bitumen binder of grade VG 30.20 and max size, that is maximum size of aggregate, is 50 mm. Bituminous penetration macadam. The coarse aggregate of specified size are first spread and compacted well in dry state. Compacted thickness from 50 to 75 mm. After compacting of dry aggregates, hot bituminous binder of specified grade is spread in large quantity on the top of this layer, filling up a part of void and binding by key aggregate. Built-up spray grout. It consists of a two-layer composite construction of compacted crushed stone aggregate with bituminous binder applied after each layer and key aggregate placed on the top surface of the second layer. Base course. The base course is immediately beneath the surface course. It provides additional load distribution and contributes to drainage and frost resistance. Base courses are usually constructed out of Aggregates. Base cores are most typically constructed from durable aggregates that will not be damaged by moisture and frost action. Aggregates can be either stabilized or unstabilized. So, sub-base cores. So it must be intermediate layer between subgrade and granular base cores. Essentially, a drainage layer distributes the stress imposed by traffic. Function of sub-base cores of flexible pavement. It functions primarily as structural support, but it can also help minimize the intrusion of fines from the subgrade into the pavement structure, improve drainage, minimize frost action damage, provide a working platform for construction. The subbase generally consists of lower quality materials than the base cores, but better than the subgrade soils. Materials for subbase. So, what materials are used? Locally available materials. They are natural sand, gravel or murum, concrete, crushed stone, laterite, and industrial waste and other materials. It may be steel slag, pond ash or pond ash bottom ash mix, crushed concrete, brick beds. Subgrade. It forms the foundation of the pavement system. Subgrade soils are subjected to lower stress than the surface, base and subbase cores. Since low stress decreases the depth, the controlling subgrade stress usually lies at the top of the subgrade. The combined thickness of subgrade base and wearing surface must be great enough to reduce the stress occurring in the subgrade to values that will not cause excessive distortion or displacement of the subgrade soil layer. Factors to be considered. So, what factors must be considered here? The first, general characteristics of the subgrade soils. Then, depth to bedrock, depth to the water table, compaction that can be attained in the subgrade, CBR values of uncompacted and compacted subgrades, presence of weak or soft layers or organics in the subsoil, and susceptibility to determine frost action or excessive swell. So as you can see that there are some methods for subgrade preparation. The first is compaction. Let's consider it. Infill area subgrade below the top 150 mm, that is 6 inches, is often considered adequate if it is compacted to 90% relative density. In order to achieve these densities, the subgrade must be at or near its optimum moisture content, that is the moisture content at which maximum density can be achieved. Usually compaction of in situ or field subgrade will result in adequate structural support. Stabilization. The bending characteristics of these materials generally increase subgrade load-bearing capacity. Typically, lime is used with highly plastic soils, plasticity index greater than 10. Cement is used with less plastic soils, plasticity index less than 10, and emulsified asphalt can be used with sandy soils. For flexible pavement, a prime coat is not effective on silty clay or clay soils because the material cannot be absorbed into such a fine soil. Over-excavation. The general principle is to replace poor load-bearing in situ subgrade with better load-bearing fill, typically 0.3 from 0.3 to 0.6 millimeter, from 1 to 2 feet.